I'm Eddie Buchanan, a Division Chief with Hanover Fire and EMS in Richmond, Virginia, and a past president of the International Society of Fire Service Instructors. The fire service has been familiar with Size Up for a while now, but it's important to refresh on the basics and look at how fire dynamics research has given us more tools we can use on the initial arrival. As we know, Size Up starts long before the call comes in. Firefighters should be familiar with the construction and occupancy types that exist in their response area. Anytime new construction occurs, you should be out making site visits to observe the construction techniques and floor plans in case you have to return for an emergency. We have discussed modern fuels in previous videos, but it's still important to remember that modern fuels release more energy faster and consume more oxygen than legacy fuels. When you couple this with larger homes and open spaces within the lightweight building construction, and then put that on a smaller lot, you have a dangerous cocktail of circumstances that places firefighters and civilians at greater risk than ever before. So what does this mean when you're sizing up an incident? You can expect faster and more violent fire growth, less time to get your handlines in position once you've opened the building, and potentially rapid changes in fire dynamics based on what you do when you arrive.
These observations that we make as we go and do our 360 around the building or observing the building from the outside, traditionally, that's all we see when we first get up on the scene is the outside of the building. The research allows us to marry up that outside picture with what's going on the inside. So by looking at the research and looking at those videos, when I make a size up now, I'm looking at smoke coming out of the building, and I can better predict what's happening inside that building based on what I'm seeing on the outside.
So aside from the many size up considerations that we've been familiar with for years, today we'll touch on the construction and conditions, the visible and non-visible indicators, and how we use these to locate the fire in the building. As the first arriving engine approaches the scene, they must quickly determine the type of construction involved. This begins in general terms during pre-planning and gets very specific on the arrival at the incident. Remember that buildings constructed during the legacy periods are typically renovated and loaded with modern fuels. In the fire service, we're used to the what have I got and where is it going thought process during size up. We essentially conduct a visual inspection of the building and the current conditions within the building to develop the appropriate action plan to control that situation. But the research has taught us that there are more considerations that are essential to firefighter safety, victim survivability, and tactical efficiency.
Tactical considerations for size up are what have I got, where is it going, and how do I stop it? The company officer must take these considerations into effect when making a tactical action plan. It's not a simple, let's go in the front door with the hand line. Now there's an actual plan in place based on these considerations.
There are two sides of the fire triangle that we can impact, the air and the heat. While there's little we can do about the fuel in the structure, we can impact the heat through the application of water. And we can impact the air by limiting the oxygen to the fire until we have the opportunity to control the heat. With that in mind, we should observe the fire building for clues that will allow us to take advantage of how we can control that quickly. If you have smoke and fire showing, consider how is it showing. Are any of the vent openings unidirectional? This would indicate the fire is getting its air supply through another location. If you see a unidirectional vent on one side of the building, be on the lookout for an air inlet as you make your size up lap. You may have the opportunity to shut down the inlet side of the flow path as you make your lap, limiting the combustion air. If you have a large volume of fire showing, you may consider a rapid exterior attack on that fire, thus rapidly controlling the heat. So we ask a few more questions during the initial size up lap. What have I got, and how do I have it? And where is it going, and why? With vent-limited fires, we may have to work harder to understand what is happening in the fire building. So evaluating what we do not see can be equally as important. As we go, we're scanning for any signs of life, from a person standing in a window to more subtle signs of life, such as handprints in a window or the blinds in disarray. We are looking for areas within the structure where an occupant is most likely to survive. An occupant behind a closed door may find very survivable conditions, where an occupant unprotected from the flow path has little chance. As we complete our lap, we have established indicators as to what conditions might exist inside of the fire building. Aside from identifying any obvious rescues, we are working to locate where the fire is in the building. This may be obvious due to the venting fire, or we may not see obvious signs of fire at all. Because we know that fires can easily become vent limited in modern fuels, the thermal imager is a critical tool during size up. We use the thermal imager to help us identify what we cannot see during the initial evaluation of the building. The term "nothing showing" means nothing is an accurate statement in a modern fuel fire. Use the thermal imager to identify signs of a fire that might not be visible from the exterior of the building. If we don't have a clear location of the fire initially, look for signs of high pressure within the building. This will help guide you to where the initial water can do the most good. In the absence of pressure and heat, you may be dealing with an incipient fire, or a fire starved for oxygen so long that it has lost the heat necessary to support combustion.
It's not uncommon for fire departments to respond to reports of a kitchen fire that's burned all day unnoticed, undiscovered, and prior to their arrival the fire self-extinguished due to the ventilation limited conditions in the fire compartment.
As the size-up starts to reveal a clearer picture of the incident, the incident commander begins consideration of where the fire is inside the building and what actions they'll take to control it. We use the information from our initial size-up to determine our action plan. We are making an assessment of the potential occupants inside and assessing which legs of the fire triangle can be managed to reduce the release of energy inside the structure. It is based on this initial assessment that the remaining steps of the SLICE-RS concept are carried out. The initial incident commander should also conduct ongoing assessments as the operations proceed. Look for changes in the neutral planes and flow paths during the operations to ensure crews are not surprised while they're operating inside. As we learn more about size-up in the modern fuel environment, we must develop an eye for indicators that warn us about the fire dynamics inside. We should study as much fire footage as possible and work to identify flow paths, neutral planes, and other indicators so we can quickly see the signs that are so often overlooked in the past. This will take practice and makes for a great kitchen table drill. But with some work, we can develop our size-up skills to rapidly identify potential rescues and the current status of the fire, along with how the fire will respond to our tactics. So from South Bend, Indiana, I'm Eddie Buchanan. Keep training and stay safe.
Hi, I'm Brian Kazmierzak, a Battalion Chief of the Penn Township Fire Department in Mishawaka, Indiana, and a Director at Large with the International Society of Fire Service Instructors. During the past few years, the term flow path has entered the fire service vernacular. What we must all understand is flow path is not new and it occurs at every fire we respond to. We must recognize flow path and be deliberate about addressing it at every fire and need to make this part of tailboard critiques and after-action reviews. James Raidwood, Superintendent of the London Fire Brigade, stated in 1866, "The door should be kept shut while water is being brought and the air excluded as much as possible, as fire burns exactly in the proportion to the quantity of air which it receives." If you think about this quote, it makes total sense. Just think about building a fire in a wood-burning stove or a fireplace and using the damper and the flue to control the draft. Also, while we have renamed Vent Enter Search to Vent Enter Isolate Search, most good instructors have taught us to close the door or control the flow path, even before we knew what it was called. Anytime we force the front door to make entry, take out a window, or cut a vent hole, we are influencing the flow path.
I remember being taught very early on in my career, maybe I was just lucky, I don't know, but that opening the door was ventilation. Your ventilation began when you made entry into the building. All right, so I knew that. I didn't really know it. I didn't really understand it. I didn't really appreciate the extent of the potential impact. And now I do, because we're seeing that when you open up that door, there's a read you can make. It's not just about the smoke is lifting and coming out the door. It's about the air track and the speed of the air track. And is that speed changing? Is it improving? Is it getting worse? And what does the timing mean? Is the biggest thing that I've gotten out of this is you appreciate how fast that one opening can affect the outcome of the fire.
Right through fire school and into probation training, they always teach you that forcible entry is opening doors and ventilation is opening windows. We have to treat it as one and the same. Any opening in the box is considered ventilation, and we have to be able to control those flow paths.
Flow path has been a major factor in several line-of-duty death and serious firefighter injury cases. Probably the most famous of these cases being the Cherry Road fire in Washington, D.C., which 2 firefighters were killed, or the most recent being case studies from San Francisco and Chicago, which were line-of-duty death reports recently released by NIST. Flow path is defined as the movement of heat and smoke from the higher pressure areas within the fire toward the lower pressure areas accessible by doors, window openings, and roof structures. Generally, unless the thermal layering is disturbed, hot air travels out on the top and cool air travels in on the bottom. Any operations conducted in an uncontrolled flow path without an attempt to limit the flow path could potentially place trapped occupants as well as firefighters at risk because of an increase in the movement of fire, heat, and smoke toward their position. The speed of the heat and smoke in the flow path has been measured at up to 15 miles per hour. You cannot outcrawl the flow path. You will become trapped in the hostile environment, sustaining serious injuries or even death.
I really don't think we can overestimate the importance of slowing down our ventilation operations and speeding up our extinguishment operations. It seems to me that there's a segment of the fire service that's got their undies in a bunch about the location of the nozzle when you first open it up. And that's an important discussion, and that's an important part of the research. But the bigger part of the research and the bigger part of the discussion needs to be controlling the ventilation and making sure that those things are truly coordinated. This is a dance that has to be more finely tuned than ever before. We're letting too much air into these fires too quickly, and we're not advancing our lines to the seat of the fire fast enough.
Ventilation should be coordinated with fire attack. Any openings on the structure that provide an inlet for air are going to spike the heat release rate. By the time we have hose lines in place, we should be ready to do our ventilation operation. When the glass breaks, water should be flowing.
I think the shift needs to be towards where the engine officer is the one making the ventilation call, with confirmation from the incident commander and other people on the fire ground. But that ventilation should not initiate independent of the decision of the engine officer making the attack to the seat of the fire.
Controlling the flow path is a means of applying tactical ventilation on every fire ground. Too often, ventilation has become a one-way operation where we simply open the building as fast as possible. This can lead to the ventilation operation getting ahead of the suppression operation, which will result in uncontrolled fire growth. Tactically ventilating requires us to manage the airflow to and from the fire compartment in order to control and perhaps even suppress the fire as we move our lines into place for cooling and extinguishment. The first step of controlling the flow path after identifying the flow path involves controlling the door that is being used for fire attack. The door must be controlled and closed as much as possible to limit the amount of air entering into the fire environment. If the door is not controlled, there will be an increase in the heat release rate, thus making conditions more dangerous for the trapped occupants. There are basically two methods for controlling the flow path in the fire ground. Both involve changing traditional methods of immediate horizontal ventilation. Method 1 revolves completely around door control. A firefighter will either be assigned to door control or the door is kept shut while the hose line is advancing on the fire. Most forcible entry instructors advocate forcing the door to the fire and holding it closed or controlling it until the line is ready to enter. While this has been taught for a while now, it must become commonplace in the fire service. In the past, however, once entry was made, most firefighters would often leave and chalk open the door, thus influencing the flow path, something that most of us never realized we were doing. A lot of firefighters have heartburn over the door closing behind them. The Los Angeles County Fire Department has addressed this by placing a flashlight at the door to help ease the feeling by giving firefighters a marker with the light. One of the downfalls of this tactic is that it does require extra staffing or the use of a RIT team member to help control the door, thus taking them away from their normal assignment. Method 2 utilizes a fire-resistant curtain that is hung in the entry doorway. These curtains are smoke-blocking devices, as they are called in Europe, have been around for a while now, but have just entered the United States in the past couple of years. As a matter of fact, most fire apparatus in Europe carry them, and every positive pressure fan sold in Europe is delivered with a curtain due to the great work of Dr. Michael Reich. In addition, the insurance industry has found them so effective that they have been the main funding source for these curtains for the fire departments. While the curtains have not become mainstream yet in the U.S. Fire Service, they do provide a great solution to door control, flow path control issues we face. With this curtain, you do not need to dedicate extra staffing to control the door. Once the curtain is hung in place, which takes less than 10 seconds, it will stay there for the duration of the fire. The curtain will help the fire stay ventilation limited, which will limit the heat release rate and dangers to firefighters working in the flow path. In addition, the curtain is very easy to crawl under and less constrictive feeling than a shut door. Several U.S. fire instructors are working with curtain manufacturers to add safety items to the curtains, such as LED lights or luminescent markings.
We found our flow path control devices or smoke curtains to be very useful. We don't use them at every fire. If we can cool the fire down from an exterior position or quickly through the door, it's not the first thing out of our toolbox. But if we go to an apartment building where we have a common stairwell, it's certainly the first thing we deploy. So it's been a great asset to us for controlling flow path in a variety of situations.
No matter which method you choose to control the flow path, if firefighters understand the flow path within a structure, they have an effective tool for reducing the risk to trapped occupants and for ensuring an effective fire attack. Examining line of duty deaths and incidents where multiple firefighters were burned has shown the speed and the hazard of thermal flows. Firefighters will see that it is important to conduct a good size up while coordinating ventilation and suppression tactics to control thermal flows. Like with any other tactic, we must realize every fire is different and no tactic is absolute. We have a lot of tools in the toolbox and we need to be able to quickly distinguish which tactics we are going to use to address the situation. From the training burns in South Bend, Indiana, stay safe and remember, through the combination of science and thinking firefighters, we will make the fire service safer for all of us.
Hi, I'm Pete Van Dorp, Assistant Chief with the Algonquin Lake in the Hills Fire Protection District. I also serve on the advisory board of the UL Firefighter Safety Research Institute. As the first in-company officer or officers are identifying and making a decision on how to control flow paths to and from the seat of the fire, they need to be developing a plan on how to safely and efficiently, meaning quickly, cool the fire. If, during the size-up, the officer is elected to initiate a defensive operation, this may mean positioning lines outside the collapse zone to cool adjacent structures and/or provide points of vantage to address the original fire building. However, if the officer is elected to initiate an offensive attack, the officer will choose an attack posture that achieves knockdown as quickly as possible in order to facilitate a transition to advancing to the scene of the fire for complete extinguishment. Cooling from a safe location helps accomplish 3 critical fire ground objectives. First and foremost, it improves conditions for anyone still inside the building by reducing the thermal and toxic threat as quickly as possible. Heat and toxic gases are moving from the fire to the victim faster than any human can move. Research has clearly demonstrated that conditions throughout the building will improve within seconds of effective water on the fire. The sooner this happens, the better. Secondly, quick water reduces the thermal threat to the building, helping prevent a room and contents fire from transitioning to a structure fire. Modern buildings are less fire resistant than their predecessors. Stopping the fire from attacking the structural components of a building allows for a more aggressive and permanent positioning of resources into the structure for search, rescue, and complete extinguishment. Lastly, though certainly not least importantly, early cooling reduces the thermal and toxic threat to firefighters as they advance into the structure. This allows them to move faster toward their objectives and accomplish them with greater speed, efficiency, and effectiveness. All fireground operations become faster, safer, and much more effective when the fire has been knocked back and controlled. Cooling from a safe location does not, in any way, shape, or form, mean that the fire must always be hit from the outside first. It simply means that you now have permission to use the reach of your stream from whatever position is most advantageous for a fast knockdown of the fire. It also means that you have an obligation to do so. If you are standing with a charged line in your hand waiting for the front door to be forced and you choose not to knock down the fire showing from the second floor window, you are deliberately exposing the victims, the building, and your fellow firefighters to an unnecessary threat. Do the right thing.
When I first started to learn about exterior water from the research, I was reluctant. I was very apprehensive about trying to do that, and the more I learned about it, if I could reduce the temperatures for the occupants, if I could make things better for my firefighters trying to get in and make that rescue, it wasn't that, why would I do that? I couldn't argue why I wouldn't. It's the right thing to do.
Cooling can happen through an almost infinite combination of positioning and stream selection combined with line advancement and nozzle techniques, but it will most often be initiated in one of the following ways. 1, cooling the gas layer overhead by flowing water into it prior to advancement. Water should be flowed until droplets are seen and felt to be returning from the smoke layer. 2, cooling the entire area ahead of your advance with a sweeping or arcing motion of the nozzle. 3, cooling the fire compartment using the reach and penetration of your stream. This can be from either an interior or exterior position and should be done from the position that gets effective water to the fire as fast as possible. 4, cooling a void space before or as you expose it. Let's look at cooling the gas layer. We should be long past the point where we think you don't put water on smoke. Smoke is fuel, hot, toxic, potentially explosive fuel. We should never advance into or under a fuel-rich atmosphere of hot, toxic gas. A hot gas layer is pyrolyzing more fuel as it moves through the structure, making conditions worse. Cool it. There may not be a clearly stratified smoke layer as you advance into a structure. The smoke layer may be too low to get under, or heat conditions may be preventing your advance. In cases like these, you may elect to cool the entire area ahead of you, gases and surfaces alike, with a sweeping, arcing, or whipping motion of the nozzle. As with gas cooling, the idea is to recognize that your entry into the environment and any ventilation operations will bring air into a hot, rich fuel atmosphere that needs to be cooled to prevent violent fire growth. Using the reach of your stream to cool the compartment before you advance on it may well be the most effective tactic. It gets the most water to the source of the problem as soon as possible. When done on the interior of the building, it may often be combined with gas cooling and sweep and advance techniques. When done from the exterior of the building, it comes with 2 important caveats. First, never, and we mean never, use a fog pattern of any type when operating a line through an exterior opening into a structure as part of an offensive operation. Similarly, never whip a stream as you play it into the window. Both a fog stream and a whipped straight stream will entrain a great deal of air that can actually reverse the natural convection out of the window or door. At the same time, the water pattern is physically blocking the ventilation opening. This combination of blocking the opening while entraining air into the structure is likely where the idea of pushing fire originated. You are effectively changing the flow path with your stream. This can and must be avoided. In addition, get close to the opening in order to get the stream to enter the window at an acute an angle as possible, bouncing the stream off the ceiling or walls, thereby replicating the effects of a sprinkler head.
Cooling the fire from the exterior is much more than just throwing water in through a compartment opening. If you flow the water through the opening at a horizontal pattern, strike it off the back wall, for example, you'll cool the back surface of the wall and have limited impact on the overall temperature in the compartment. Angling the stream up a little higher, having it disperse off the underside of the ceiling, you'll cover more of the contents within the compartment and maximize the cooling.
Cooling from a safe location is nothing new. It is a tactic that was used by our forebears because they had no choice due to lack of SCBA and bunker gear, and that should be used by us because it positively impacts interior conditions for victims and rescuers alike. The historic objectives of cover the exposures and confine the fire prior to extinguishment were early manifestations of the same idea of preventing fire spread prior to executing fire extinguishment. Revisiting the importance of these objectives is especially relevant in today's fire environment where exterior foam insulation and vinyl siding have accelerated fire spread from floor to floor via auto exposure out of the windows. We believe that adopting the concept of cool from a safe location accomplishes these objectives while at the same time prompting the officer to remember that he has adopted an offensive strategy that requires a tactical transition toward complete extinguishment at the seat of the fire. Cooling from a safe location can also be thought of as simply resetting a post-flashover fire to pre-flashover-like conditions, allowing for a more aggressive posture within the structure. It is also a method for cooling a ventilation-limited fire area prior to extensive ventilation in order to prevent flashover and other violent fire development from occurring. A truly coordinated fire attack requires that ventilation and suppression move forward at the same pace, and that requires early cooling. Another part of the cool from a safe location methodology is to expose and cool concealed spaces and voids as early in the firefight as possible. Modern residences have more interconnected void spaces than ever before. These spaces can easily become filled with explosive mixtures of heat and smoke. Fire officers need to anticipate and plan for explosive void space fires at every incident. When voids are being opened, they need to be cooled immediately. Do not wait for the fire or smoke to push out of the opening, and do not wait to get it all opened up first. Remember, you can't see or feel most of the potential problem yet, so get it wet. Taking a beating inside a building is not what makes your firefight an aggressive one. An aggressive firefight is one that allows you to move quickly to your objectives and effectively accomplish your mission. By now it should be evident that SLICE-RS is an acronym designed with an aggressive interior firefight in mind. The decision to adopt an offensive or defensive strategy is made early in the process, just as with any other approach to a firefighting incident action plan. Once the decision to go offensive has been made, the priorities of locating the fire, identifying and controlling the flow path, and cooling from a safe location are designed to help the officer best accomplish the ultimate goal of complete extinguishment. Extinguishment is not an automatic outcome or end result of accomplishing the prior objectives. Modern fires and modern buildings quickly transition from room and content fires to structure fires. The amount and toxicity of modern fuel loads is greater than ever before. The volatility and combustibility of modern fuels and the smoke they produce makes reignition more likely and more violent than in the past. Add these considerations to the traditional list of reasons why we need to get into and occupy the structure as fast as possible. As the first companies move in for complete extinguishment, they need to be cognizant of the need for additional ventilation, backup lines, lines to cover interior exposures and fire spread through the voids, and lines to support and protect search teams. The conditions of the utilities need to be taken into account. The condition of the structure needs to be continually assessed. In short, there is still a whole lot of work to do and a great deal of information that needs to be gathered and processed. The principles of modern fire attack and the SLICE-RS system are designed to assist the first arriving officers with organizing and meeting the critical objectives of the first few minutes of the incident, while making effective use of information and insights gained from recent research into fire dynamics and the characteristics of lightweight construction. As more companies and command arrive on the scene, the operation can and should be fleshed out using RISI OVS or any other command organization system that meets the needs of the incident. From South Bend, Indiana, this is Pete Van Dorp. Please keep safe out there.
Hi, I'm Jim Silvernail, a Battalion Chief with the Metro West Fire Protection District in St. Louis County, Missouri. I'm also a Western Regional Director of the International Society of Fire Service Instructors. Let's talk about the rescue component of SLICE RS. The priorities of structural firefighting remain constant: to save lives, to protect property, and to minimize harmful impacts to the environment. The SLICE RS application has not changed this, nor has it placed a lower priority on rescue.
Rescue always has been, always will be, our strategic priority. That doesn't necessarily make it the tactical priority at any given time. It makes me really nervous when I hear fire chiefs developing rescue modes and I hear officers announcing we're in rescue mode. Brothers and sisters, we are always in rescue mode. We shouldn't be changing our operation because we have a report of people trapped. That is an assumption we make at every fire we go to, and we address the situation based on that assumption. But remember that that's a strategic priority, not a tactical priority. If you can affect more rescue or save more lives or reduce harm by getting water to the seat of the fire faster, that becomes your tactical priority. That's how you achieve your strategic priority of rescue. We have to have the flexibility to do that, and really any good fireground commander and any good fireground officer always has used that flexibility. SLICE RS, I think, emphasizes that it's a flexible and a dynamic decision, not one you simply make once on the fireground and then you can move on to something else. The emphasis of making it an action of opportunity is that you have to constantly address this throughout the incident, not just when you pull up on the scene.
In this first scenario, the crew arrives on the scene. The officer immediately sees the victim and goes to the window. The officer makes verbal contact with the victim and asks the victim to remain calm and asks if he or she can close the bedroom door.
Is your door open? Can you shut your door?
My door's open.
Okay, well shut your door for me, okay? We're coming.
The crew is simultaneously deploying a ladder to the window for a rescue grab. The officer radios a progress report and orders the next new company to assume fire attack. The crew assists the victim down the ladder. Not all rescues immediately present themselves upon initial arrival. Immediate actions may be those that facilitate fire suppression and victim access. In this scenario, the engine crew will arrive to find flames showing from front windows. The crew will begin implementing the SLICE RS application. The officer will begin the size up when a frantic bystander runs up and states, "I think there's a wheelchair-bound person somewhere in the structure." The crew quickly sizes up, locates flow path, keeps the front door closed, and does a rapid reset from the front yard. This must all take place in just a few seconds. Speed is critical. The crew makes quick entry and locates the victim and begins extrication. In this scenario, the immediate action of resetting the fire by external stream application was initiated to facilitate the rescue. It accomplished two purposes. One, to improve conditions for trapped occupants and to increase survivability by lowering heat, and two, to initially control and contain the fire to improve internal access conditions for firefighters. The survivability of occupants in a structure fire is directly related to their exposure to heat and toxic gases and the amount of oxygen available to breathe.
Ventilation limited for the fire means oxygen limited for any victims in the compartment. Unless they're sheltered from the main fire area, a ventilation limited fire that's limited to the point of below 6 to 8% oxygen will have a zero survivability profile for any victims, regardless of where they are in the structure, unless they're protected from the main body of fire.
The SLICE RS application addresses this vital concept utilizing facts from science and research. Cooling the fire first makes conditions better every time. Saving lives will always be the highest priority in the fire service. That will not change, nor will the fire service stop entering structures to make rescues of viable trapped occupants. SLICE RS has not changed this and places the highest priority on saving lives. Rescue must be immediate and initiated once the opportunity is presented. However, as illustrated in previous examples, actual victim removal may be secondary to essential facilitating actions such as immediate cooling of the interior fire atmosphere. From South Bend, Indiana, I'm Jim Silvernail. Be safe.